Chapter 3, problem number 48. Two cars, A and B, are traveling in the same direction. Although car A is 186 meters behind car B. The speed of A is 24.4 meters per second, and the speed of B is 18.6 meters per second. How much time does it take for car A to catch car B? Okay, well, first of all, these speeds are relative to the street. So we have the car A, which is traveling at 24.4 meters per second. Okay, so car A, that's VA relative to the ground, is 24.4 meters per second. And then we have car B relative to the ground is 18.6 meters per second. Now the story begins when car A is 186 meters behind car B. Okay, so here's car A, and here's car B. Okay, so car B has a velocity VBG, and car A has a velocity AG, velocity A relative to G. The distance between them is given. Okay, so we have a displacement, delta x, of 186 meters. And again, the unknown is how much time does it take car A to catch car B. So what we're going to do is, let's put ourselves in the reference frame of car B. So we're going to figure out the velocity of car A relative to car B. And then knowing that, we can find the time because we know delta x. Okay, so here we go. So VAB plus, VAB, yes, plus, we're going to put VBG here. Okay, and I did that because we want this subscript and that subscript to be the same. So if I add those two together, I get the velocity of car A relative to the ground. Now what I'm going to do is solve for VAB. So VAB, the velocity of car A relative to B, is equal to velocity of car A relative to the ground minus the velocity of car B relative to the ground. Once we know that, we can set that equal to delta x over delta t. So delta t, the time it takes car A to catch car B, is equal to delta x over the velocity of car A relative to car B. So we have then 186 meters divided by VAG, which is 24.4 meters per second, plus a negative VBG, which is 18.6 meters per second. So the time then is equal to, I'm going to do the denominator first. So I get 32 seconds. Is the time it takes car A to catch up with car B. This problem reminds me of another problem that you might have encountered where you have two bicycles, let's say, approaching each other at 5 meters per second relative to the ground. So relative to one of the bikes, the other bike is traveling at 10 meters per second. Now let's say that the bikes are, let's say, 50 meters apart. So how long does it take the bikes to collide? Well, essentially what you have then is one bike traveling at 10 meters per second relative to the other bike, which is at rest, over 50 meters. So we have the equation of 10 meters per second is equal to the distance, 50 meters, divided by the time. Solving for time, we have 50 meters divided by 10 meters per second, so we end up with 5 seconds. So it takes 5 seconds for the two bikes to collide. Now suppose there's a bug flying between the two bicycles, and let's say the bug can fly at a speed of, let's say, 20 meters per second. So the question is, how far does the bug travel between the two bikes before being squashed? So we have the bug speed is 20 meters per second. We can set that equal to the distance the bug flies between the bikes back and forth before being squashed, divided by the time it takes the bikes to hit, which I believe we said was 5 seconds. So solving for distance, we get 20 meters per second, the speed of the bug, multiplied by 5 seconds, or 100 meters. So the bug will fly through 100 meters before being squashed by the two bikes when they collide.